Hi everyone, my name is Premalatha. I am working in the School of Computing Science and Engineering, VIT University. Today, my concept is minimal cover in functional dependencies. Before going into the concept, let us discuss the basics things. Now, the first concept is functional dependency. If suppose we say that A determines B, it means that B is functionally dependent on A. Now, we can explain this with an example. We have a customer ID determines customer name. It means customer name is functionally dependent on customer ID. Technically, we say this concept as customer ID determines customer name. Otherwise, customer name is functionally dependent on the customer ID. This is functional dependency. Now, we are into the finding minimal cover. We have three steps in finding the minimal cover. The first step is to decompose all the right hand side attributes as the singleton attributes. That is, there should not be more than one attribute towards the right hand side. If that is the case, decompose all the functional dependencies. And the second step is to identify the extraneous attributes and we have to remove it. Extraneous attribute is which is of no use. We can say it as an extra attribute that will be explained in detail in the forthcoming slides. The third step is to remove the redundant dependencies, that is the unwanted dependencies. So, the first step is to find the singleton attributes in the right hand side. So, let us consider the functional dependency AB tends to CD. Now, what we are going to do is, we are going to divide this CD into two functional dependencies. We say this operation as decompose, or else we are just dividing this as AB tends to C and AB tends to D. In Armstrong axioms, this is coming under decomposition. And attribute closure. Now we are going to find, before going into the concept of finding the minimal cover, the basic thing we have to know is to find attribute closure for each attribute which is acting as a key attribute. So let us consider this dependencies. A tends to B, B tends to C. Now if we have a functional dependency like this, first find A closure. A closure in the sense A is giving B. So what we can do is, it is giving A, B, because we can say this AB has arrived because of the functional dependency A tends to B. Now the second step is, since A has already arrived with B, B is arrived with C. So second step is giving A, B, C, since we have B tends to C. So A closure value will be A, B, C. Now the second closure is B closure and B is giving C, so we are giving BC. So A closure gives you ABC and B closure gives you B and C. Now finding candidate key for these dependencies is based on these closure. If a closure gives all the attributes which is specified in the schema, then we can say this attribute as a candidate key. So we are determining that A is a candidate key and B doesn't have A here. So we have ABC here. A closure has arrived with ABC and B closure does not have A. So A is a candidate key. Now coming to the second example of the attribute closure. So in the first step we have seen that the attribute closure have only one attribute towards the left. What if we have more than one attributes towards the left? And how we are going to find the dependency is what we are going to discuss it now. So let us consider the schema. We have A, B, C, D, E and F, and let the functional dependencies be AB tends to C, AD tends to E, B tends to D, AF tends to B, B tends to C. Now we are going to find the closure for A and B. So A, B is issuing C. So we will have A, B and C. Now we have to check whether we have any dependencies for B or for C, or for the combination of BC, or for the combination of AC. Now since B is arrayed with D, we can include along with this ABC D also. Now and then followed by D. Since we have got AD tends to C, we have already A and D in this closure, so we can arrive with E. So with all these functional dependencies, we have arrived with A, B, C, D, E for AB closure. Now coming to AD part. Now AD is arrayed with E, so we have just ADE. And since we don't have any DE towards the left hand side, D towards the left hand side, separately E towards the left hand side. So this is all about AD closure. Now coming to B closure, B have only D, so we have B and D as B closure value. Now the next step is to find the candidate key. Since we have A, B, C, D, E, F here, AB closure has given A, B, C, D, E and F is missing. Here so we cannot arrive with the candidate key, since AB is not giving all the attributes in the schema, and AD is not giving, and B is also not giving. Now let us try it for AF. Now AF closure gives you AFB. So AFB is, we have to check is either we have any the dependency for A separately, F separately, B separately, and AB separately, or FB separately. Fine. Since we have AFB which is already arrived, we have, since we have A, F and B, AF is arrayed with B, so we have given AFB. Now this B is issuing C. From this we have B is issuing C, so we have added this C here, and now we have to check with the left hand, other parts of the left hand side. So we already have AF, it is arrived, already have B, it is arrived, and B is also giving D, so we can give D also. So AFB we have got, B tends to D we have got, and AB tends to C. So here we have A and B, so and this A and B is arriving with this C. So at last A and D is arriving with this E. So with all these functional dependencies, we have A, F, B, C, E and D. So since we have got all the relational schemas here, we can say AF is a candidate key. Now let us arrive with the third example. We have A tends to C, C tends to B, and D tends to E. Now A closure will give you A tends to C, so AC, and C is issuing B, so it will become ACB. So A closure is giving ACB, and C closure is giving C tends to B, so it is giving just C and B, and D closure is giving D and C, since we do not have any other E in the left hand side, so it is just arriving D and E. Now since we do not have all the attributes in any of the closure, we have to find our own candidate key by combining the attributes towards the left hand side. So let us check with this A and D. Now if you try to find the closure for AD, it gives you AD, and A is issuing C, so we have arrived with AC, and D is issuing E, so we have arrived with E, and C is arriving with, that is C is issuing B, so we have arrived with B. Since all the attributes have arrived, we can say that AD is a candidate key. And we are into the fourth example of attribute closure. Now we have A tends to B, C tends to D, BC tends to E. If we find A closure, it is giving AB, since we have AB, and C closure is issuing CD, since we have C and D, and BC closure is giving BCE, because BC tends to E we have, so we have BCE. Since C is arrayed with D, we can include this D also here. So now let us consider extraneous attributes. Now the second step for finding the minimal cover is extraneous attributes. Now we are into the extraneous attributes. How can we find the extraneous attributes? The first step for finding extraneous attributes is first take all the LHS which has more than one attribute. So we have AB tends to C here. Now we have AB tends to C. Now we have to take only these two attributes and then find the closure for A and B. Now A closure is giving B and AB along with is it gives C. So we can say A closure gives ABC because of A tends to B and AB tends to C. Now B closure gives B alone. Now if a closure gives only its own attribute as a result, then this attribute in this dependency is extraneous. So we can say that B is extraneous in AB tends to C, and we are going to remove B. Now the new set of functional dependencies are A tends to B, A tends to C, D tends to A, AC, and D tends to E. Now the new set of functional dependencies are A tends to B, A tends to C, D tends to AC, and D tends to E. Now we are into the concept of finding the minimal cover. For finding minimal cover, obviously we have to do three things. One is doing the singleton attributes towards the right hand side, and then removing the redundant dependencies. We will arrive with minimal cover, and by removing the extraneous attributes also. Since we do not have any there is more than one attribute towards the left hand side, extraneous attributes is being not implemented here as of now. Now first we have to see, that is the attributes which has more than one attribute in a functional dependency, and that is D tends to AC. So what we have to do is, this is being specified as A tends to B, A tends to C, D tends to A, and D tends to C. So this is being divided, that is decomposed into D tends to A and D tends to C, and then we have D tends to E. So now we are going to consider this, and then we are going to find the redundant dependency. Now what is the first step for finding the redundant dependency is, if we have a set of dependencies, we have to keep on avoiding each dependency, and then we have to find the closure. Now let us remove this A tends to B from this given set of functional dependencies, and then find A closure from this part alone. Now we have A, C alone. Now if you remove this A tends to B, and see, we have missed this B from the entire set of functional dependencies. So we could not say that A tends to B might be redundant, because if we remove this A tends to B, obviously we are missing this B attribute here. Now the second step is removing A tends to C and then finding the closure for A. So if you try to remove this A tends to C, your A closure will gives you only A tends to B. So B is not acting as any of the key attributes, so it is arrayed with only A and B. Since you have removed A tends to C functional dependency, and since C is not arrived in this closure, we cannot say this A tends to C is redundant, and we are not going to remove this functional dependency. And the third is D tends to A. Now if you try to remove this D tends to A and find D closure, it is arriving with DC, so it is giving DC, and D is also arriving with E, so it gives DCE. In D tends to A has not arrived, So we are not supposed to remove this dependency. So we are not removing this. The fourth step is to remove D tends to C. So if we remove this D tends to C and we are trying to find D closure, D is giving A. So we have given DA and D is giving E. So we are giving E and A is giving B. So we have given B here and A is giving C. So D, A, E, B, C is arrived. Since C has arrived without this dependency D tends to C, we can say that this D tends to C is redundant in the given set of functional dependencies. If that is the case, we are going to remove this D tends to C from the given set of functional dependencies. Now, after removing, this will be the new functional dependencies. Again, we have to start from this. So the fifth step is to remove this D tends to E and then to find D closure. So this D closure gives, so D, A, we have given DA and A is giving C and A is giving B. So we have given DA, C, B. So this cannot be a redundant functional dependency because E has not arrived in the closure part. So we have removed two functional dependencies, that is one is this D tends to A another is A tends to C. So this and D tends to C. So A tends to C and D tends to C are redundant, and this is the final minimal cover. Considering the next example, so we have A tends to B, B tends to C and A tends to C. What we are going to do is we are going to remove this dependency first and then we are going to find A closure. So if we try to remove A tends to B, now we have arrived with A closure. Now this A closure gives just A and C. So A determines C. Since B is missing, this cannot be redundant and we are not supposed to remove this A tends to B. The next step is to find B closure after removing this B tends to C. So if you try to remove this B tends to C, we don't have any dependencies which have B. So obviously it gives only B, and since C is not arrived, we are not supposed to remove this B tends to C. Now considering the third dependency, we try to remove this A tends to C and that gives A closure as A tends to B. So A and B are arrived. Since B is issuing C, we have arrived with A, B and C. Since A closure has arrived with A, B, C without the dependency A tends to C, we can say that here A tends to C is redundant. So the final minimal cover, that is after removing the redundancy, the minimal cover functional dependencies are A tends to B and B tends to C. And this is another example which includes removing extraneous attributes and finding minimal cover. So let us take this schema which includes A, B, C, D and E, and the functional dependencies be A tends to D, B, C tends to A, D, C tends to B, E tends to A, E tends to D. The first step is to consider all the right hand side attributes as singleton attributes. Since we have arrived with two attributes for BC and D, BC towards AD, so we have BC to A and BC to D. So this is the functional dependencies after applying singleton towards the right hand side. Now the second step is to check whether we have any extraneous attributes towards the left. Now we have two dependencies which has more than two that is one attributes towards the left, and let us consider that, and let us consider the closure for B and C attributes alone. Now B closure gives B alone, since we do not have any B dependencies here, and C closure gives C is issuing B, so we can say it as BC or CB, no problem. And since we have BC which is issuing A and BC issuing D, we can add that also. So C closure is issuing C, B, A and D. Now since B closure is issuing only B, this B in BC tends to A dependency and BC tends to D dependency is extraneous. So what we are going to do is, we are going to remove this B from both the functional dependencies. So it gives, after removing these two B's, so we give we have A tends to D, C tends to A, C tends to D, C tends to B, E tends to A and E tends to D. Now the third step for finding the minimal cover is to remove all the redundant dependencies. Now as usual, we have to remove each dependency and then we have to keep on finding the attribute closure. So first let us remove this A tends to D and then find attribute closure. If you remove A tends to D, no other dependencies we have which starts with A, so it gives just A. Since D is not arrived, it is not redundant. Now remove C tends to A. If you remove C tends to A, it is giving C issues D and C issues B. So it is arrived with C, D, B. Since A is not arrived in this closure, this dependency C tends to A will not be a redundant dependency. Now the next step is to find C tends to D. Whether if we remove this, it will be a redundant dependency or not. Now if we remove the C tends to D and to find C closure, so C is issuing with A, so we have given CA. A is issuing D, so we have added D, and C is issuing B, so we have added with B. So we have C, A, B, D. In this C tends to D, even after removing this D has arrived. So we can say in this dependency C tends to D is redundant. So we are going to remove this and then only we are going to the next step. Now the new set of functional dependencies after removing C tends to D is this. Now we are into this part now. So now we are trying to remove C tends to B and then find C closure. Since C is issuing A and A is issuing D, so we have C, A, D. Since B has not arrived here, it cannot be redundant. And the next step is to try removing this E tends to A, and E tends to A, if we remove, E is already issuing D, so it issues only E and D, and we don't have any other dependencies for D, so this is all about the E closure. Since A is not arrived in this closure, we are not supposed to leave remove this E tends to A. Now we are trying to remove this E tends to D and to find E closure. It is giving EA, so we have added EA, and A is issuing D, so D. So even after removing E tends to D, this D is arrived and E is also arrived. We can say this is redundant. So this is not D not arrived, this is D arrived, sorry. And finally the minimal cover is A tends to D, C tends to A, C tends to B, E tends to A. Now since any of these closures, that is A closure, C closure, E closure, has not arrived with all the attributes, we do not have a candidate key. So what we are going to do is, we can combine any part of the dependencies and then we can find a closure. So if we try to combine this EC and to find a closure, this will give all the attributes which is there in the schema. So we can say EC will be the candidate key. And thank you for listening my lecture. Thank you.